So this video is on trig substitution. Now when we are doing trig substitution, we're primarily dealing with three equations or three functions. So these three functions are root a squared minus x squared, root x squared plus a squared, and root x squared minus a squared. So now we'll use trigonometric substitutions when we have any integration involving any of these functions within the integral. So in the case of a squared minus x squared for our trigonometric substitution, our x value will equal a sine theta. Our dx value within the integral will equal a cosine d theta, and then our root itself within the integral will equal, so in this case the a squared minus x squared itself within the integral will equal a cos theta. For our root x squared plus a squared, our x value will be equal to a tangent theta. Our dx will be equal to a secant squared theta d theta. And our, once again, the root itself within the integral, so in this case x squared plus a squared within the integral, that value will be equal to a secant theta. And then finally, the last of the functions that we will use trigonometric substitution for when they're involved within an integral is x squared minus a squared. So in this case, our x value will be a secant theta. Our dx value will be equal to a secant theta tan theta d theta. And finally, the root itself, when it's in the integral, so in this case x squared minus a squared, will be equal to a tangent theta. So now an example of an integral in which we can use trigonometric substitution is the integral before me now, which is the integral of x to the 4 over root 1 minus x squared dx. Now when looking at the formula, the first thing that you have to figure out is which of the roots is it. Is it a squared minus x squared? Is it root x squared plus a squared, or is it root x squared minus a squared? So in this case, I have been able to figure out that it is in fact root a squared minus x squared, with, in this case, our a squared being 1, and because our a squared is 1, that means our a value is 1. And that proves to be really important, because in this scenario, if our x is equal to a sine theta, then in this case, it will be 1 sine theta, or simply sine theta. Similarly, our dx value will be equal to a cos theta d theta, which in this case is 1 cos theta d theta. So it's cos theta d theta itself. And our root of 1 minus x squared in this scenario, the root will be equal to a cos theta, which once again in this case is 1 cos theta. So now what we essentially have to do is we have to plug in for our values based on our trigonometric substitution. So now if we plug in, our x to the 4 will become sine to the 4 theta. Our root function at the bottom of the integral will become cos theta, and our dx on the outside will become cos theta d theta. So now what we have to do is we can see that there's simple cross multiplication between cross out here, so this cos theta disappears, this cos theta disappears. So we will be left with the integral of sine to the 4th theta multiplied by d theta. So now once we're at this point, what we will likely have to do to find this integral is, if you remember the previous videos where we dealt with reduction formulas and the many forms of trigonometric integrals, we'll have to go back into a few of our equations to find the integral for sine to the n theta. But nonetheless, if we now look and we plug it into the formula, we'll get, by using our formula for sine to the n theta, we'll discover that the integral for sine to the 4 theta is negative sine cubed theta cos theta over 4 plus 3/4 times the integral of cos squared theta d theta. So now we're tasked with finding the integral for this value here, which is our integral of cos squared theta d theta. And once again, when we go into our equations for trigonometric integrals, we can find that value as well. So that comes out to be, we still have our negative sine cube theta cos theta all over 4 plus 3/4 times our value for our integral here, and our value for our integral there, when using the trigonometric integral formulas, will give us theta over 2 minus 1/2 sine theta cos theta all plus c. And now finally what we are tasked with doing is we must be able to state each of our thetas in terms of values of x. So now if we look at them one by one, if we know that x is equal to sine theta, then logically sine cubed theta will be equal to x cubed. We can state cos theta in terms of x because if we look up here at our at this function 1 minus x squared, it is in terms of x, and that is equal to 1 cos theta. So our value for cos theta will be root 1 minus x squared, and then it'll still be all over 4, plus 3/4. Now this is where it gets a little bit trickier because we're looking for our value of theta, but if we, in terms of x, but if we examine our value of theta here in terms of x, simply all we'll have to do to get theta here is we'll have to go make it arc sine of x will be equal to theta as the sine's been moved to this side. So in this case, we'll have arc sine of x over 2, as that's our theta in terms of x, minus 1/2, once again, sine theta is simply equal to x, so minus 1/2 of x, and then once more cos theta is in terms of x is equal to root 1 minus x squared, and then that entire bracket plus c. And using our trigonometric substitution, that is our integral or integration value for the integral of x to the 4 over root 1 minus x squared dx.